Hello and welcome. This is going to be the lesson on classification of matter. Now, last time I went over the phases of matter and I explained the properties of the phases of matter from a atomic point of view, and that's a way of classification as well. So you can classify matter according to its phase, solid, liquid, gas, or plasma. Or you can classify matter according to composition, and that's what I'm going to cover today. So you'll see this flow chart that I have, and we can classify matter according to different questions we ask about the matter. So in this box here, this is going to be matter. So all matter would be divided into several different categories based upon how we answer these questions. So the first question we're going to ask ourselves is it variable in composition? So basically what that's asking is, does the composition change and still keep the same thing, right? So if the answer is yes, it does. It does vary. Then you go over here. So if it's yes, you go over here. And if it's no, and then we'll go over here. So if no, there is no variability. Like it stays the same no matter what. No matter where you get it, no matter how much of it you have, then that is what we're going to call a pure substance. So substance, pure substance. So pure substances is anything that does not change its composition regardless of where you find it, how much of it you have, anything like that. If it does vary in composition and yet stays the same thing, same sort of matter, then we're going to call that a mixture. So that's the first division of matter into pure substances that don't vary in their composition, and then you have mixtures that do vary in their composition. And you can see this in mixtures very easily that you can change. You can have a mixture of something, so like salt and pepper. You can mix salt and pepper together, and you can vary the composition. You can have so you can have 1 gram of salt with another gram of pepper. Have equal amounts, or you might have half a gram of salt and a whole gram of pepper, and so it's still a mixture of salt and pepper, regardless of how much you have. So it's still a mixture, regardless of the composition. Whereas, for example, pure substance, you might think a pure substance, an example would be water, right? So water is always, so this might be salt and pepper. And over here we might have water. So water has a certain composition. It's made up of 2 hydrogens and 1 oxygen. So no matter where I find water, whether it's in my sink or in the lab or in the ocean or whatever, water is still going to be H2O. If it's not H2O, it wouldn't be water. So you can't vary the composition of water and still have water, whereas you can vary the composition of salt and pepper and still have a mixture of salt and pepper. I hope that's clear. Okay, so now we can break up substances, pure substances, into 2 further categories by asking the question, is it separable into simpler substances? Can I break it down into simpler things, right? If I can, so if the answer is yes, oops, let me put yes over here. So if it is yes, if I can break it down into simpler substances, we're going to call that a compound. So my water example is an example of a compound. So we'll write that down here. So if we have pure water, we're not talking about salt water in the ocean, but pure water. So pure water can be broken down into simpler substances, hydrogen and oxygen. So if I do electrolysis, meaning if I run electricity through water, I can get the water to break up into oxygen gas and hydrogen gas. And so those gases are simpler substances than the water I started with. So water would be a compound. If I can't break it down, if it's not separable into simpler substances, then we're going to call that an element. Okay, so elements, things like helium, hydrogen, right, hydrogen gas, um, these cannot be broken down into simpler substances. I might be able to break the hydrogen into atoms or ions, but it's still hydrogen, right? I didn't make it into something else, right? So I didn't really break it down into simpler substances. So elements are as simple of a substance you get, things that, you know, keep their properties. Um, and compounds are the other pure substances that can break down into simpler substances. And notice that they both have a constant composition. H2O is always 2 hydrogen and oxygen. Helium is only helium. Hydrogen is only hydrogen, H2. It's always H2 gas, if you will. Now, what about mixtures? It looks like we could break down mixtures into 2 categories. And we could do this by answering the question uniform throughout. Is it uniform throughout the mixture? Meaning, does it look like one substance or does it not look like one substance? That's the main issue. That's the main question. So if it looks like one substance, that means it's uniform throughout. It's mixed completely together, and you don't have more of one substance in the mixture together on one side versus another side. So it's all spread out uniform throughout the mixture, so it looks like one substance. If it's uniform, if the answer is yes, then we're going to call that a homogeneous mixture or homogeneous mixture, however you want to pronounce that. So homogeneous mixtures. Those would be mixtures that again look like one thing. So for example, salt water. So if I take some salt and I dissolve it in water really, really well so that it's all dissolved, and I've asked you if you didn't know it was salt water, and I've asked you, is this one substance or two? You would say it's one substance. It's water. It looks like water, right? Um, but unbeknownst to you, it is a mixture of salt and water together. So Kool-Aid is another example. Orange juice is another example if you're not counting the pulp, right? So if it's not non-pulp orange juice, you look at the orange juice, it looks like orange water, right? So you would think it would be one substance. So this would be like salt water, Kool-Aid, orange juice without pulp. I won't write that down. But what if it is not uniform? So no, it's not uniform. In this case, we would call it a heterogeneous mixture or heterogeneous mixture. So again, these are going to be where it's not uniform throughout. So basically, when you look at it, it's obvious it's more than one thing put together. So an example would be a chocolate chip cookie, right? You look at the chocolate chip cookie, it's obvious it's more than one thing because you can see chocolate chips, which is a conglomeration of chocolate in one area, right? Versus the cookie dough or whatever, right? Another example would be wet sand, right? Water and sand mixed together, right? So it's obviously more than one substance. It looks like more than one substance. So anything that looks like more than one substance as a mixture, it's going to be a heterogeneous or heterogeneous mixture. So let me write that down. So this would be like wet sand, or uh, chocolate chip cookie, right? Birthday cake is another example. You look at the birthday cake, it's obviously more than one thing, although it is a mixture. Um, so these are the distinctions, the categorization of matter according to composition. Now, you can remember this insofar as what I had just said. So elements, if you're not sure if it's an element, elements are the things on the periodic table, right? So if it's on the periodic table, it's an element. It's not a compound, okay? Now, you might be looking at this H2 and it's like, well, that isn't that a compound? It's got two H's. We'll get to that in a moment. There's a distinction between a molecule and a compound. So you can be a molecule and yet not be a compound. Um, so anything on the periodic table is an element. So if you're not sure, look on your periodic table. If it's not there, it's not an element. And then compounds, those are going to be things with more than one element combined together. So you look at the formula, and if it's more than one thing bonded together in a formula, then it's going to be a compound. And again, to distinguish between these two, you ask yourself, does it look like one thing or more than one thing? If it's a mixture, if it's a homogeneous mixture, it's gonna look only like one thing. If it's a heterogeneous mixture, then it's gonna look like more than one thing. Another example that just came to mind for a homogeneous mixture is things like brass, right? Mixtures of metals. So if you look at brass is a mixture of bronze and I believe copper. Can't remember off the top of my head, but it's a mixture of two metals. Maybe it's, I want to say maybe it's zinc or aluminum. Another example is your rings. Gold. Hardly anything is made out of pure gold. It's usually gold mixed in with other metals. But when you look at the jewelry, it looks like one substance. It doesn't look like a mixture, but it most likely is going to mixture unless it's pure gold, which probably not going to be the case for most jewelries. Okay, now that's it for this lesson. In the next lesson, we'll talk about different kinds of change. We'll categorize changes. Thank you.